So look at this equation, y equals the f of negative x. Do you notice how it's different from what we looked at in the last lecture? For this one, the negative was outside of the function. We were changing y. Now we have x, or the negative, inside the function. We're going to be changing x. So if you think about those key points that you've memorized, this time we're finding the negative of x and y is staying the same. So if I had a point here at 1c, it's going to become negative 1c. A point here at 0c, well, the opposite of 0 is still 0. And then this point becomes positive 1c. It's exactly the same line. But this was a reflection across the y-axis. The point 1, 1 moved to negative 1, 1. And the point negative 1c moves to positive 1c. We're reflecting across the y-axis. So what about our linear function? We have a point on our original graph at 1, 1, but the x becomes the opposite. 0, 0 remains because the opposite of our 0 is still 0. But then I have this point here at negative 1, 1. That first negative, or negative 1, negative 1, that negative 1 becomes positive 1, negative 1. You'll notice that this is a reflection across the y-axis. We're finding the negative of our x values. So 3 key points here. On the graph of f of x. What about on the f of negative x? What are the new key points? Did you notice that when we changed 1, 1 to negative 1, 1 and negative 1, 1 to positive 1, 1, we ended up with the same graph again. The key points didn't change here. So here again, we've got the graph of f of x. What will the points be on the f of negative x? Zero, 0 doesn't change, but 1, 1 becomes negative 1, 1. 4, 2 becomes negative 4, 2. How is this possible that x can be negative? Well, let's think about that. If we're looking at the f of negative 1, and I'm going to change x remember that x is negative 1. So I'm looking at the square root of the negative of negative 1, which is, of course, the square root of positive 1. X can be negative when we're finding the square root of negative x. That's a little bit tricky. But again, it is a reflection across the y-axis. Let's do the transformations for each of these. For both of them, we're looking for the f of negative x. We're looking for reflections across the y-axis. Find the new key points and graph the transformations. So we've reflected everything on the left to the right and the right to the left. Same thing here. The right is reflected across the y-axis. The left is reflected across the y-axis. Two final functions. We're both finding the f of negative x for these. We're reflecting these across the y-axis. Find the new key points and graph these. So you notice that the absolute value function, when I reflect it across the y-axis, looks exactly the same as it did before. And here we reflected everything on the left to the right, to the right, to the left, and we've labeled our asymptotes. So let's make a review of these reflections. If we're given y equals the negative f of x, if the negative is outside of the function, then we have a graph that reflects across the x-axis. When we look at our basic points, our key points that we've memorized, x stays the same and we're finding the opposite of y. When we move the negative inside the function, when the negative is on x, then we have a graph that's reflecting across the y-axis. We can see the negative on x, and y stays the same. I would make this your wallpaper on your phone, copy it and stick it on your bathroom mirror so you can look at it while you're brushing your teeth, combing your hair, putting on your makeup. You need to have this memorized so no matter what function we talk about, you remember what the transformation is.